week 2 of Virtual STEM. I'm Mr. Brown, and we are live here, well, sort of pre-recorded live here in my kitchen again. Before we begin with today, I want you to pay attention towards the end of this video. There's a very special announcement about something really cool coming up in 2 weeks, okay? Because next week is spring break. So in 2 weeks, something really cool is coming up. It's towards the end of this video, the announcement, so please pay attention, okay? Now, last week's challenge was to make an airplane. Not one, but 2. One of your own design, here's my own design, and one from the 3 different designs I gave you in that PDF file, and this was the front 4, okay? So, I went out, just like you guys, and threw my airplanes. I threw them 3 times each, and I'm going to show you those in just a second, but I'm only going to show you the furthest one to save some time here. I want to, though, however, congratulate a couple people here. Now, I usually record these a little bit late in the work week, like Monday through Friday, but I saw that a lot of people were starting to enter theirs towards the end of the week, their information, pictures, and on the sheet. So today's Saturday. I've waited, and actually right before I was going to record this, somebody entered their information and sent me a video which proves that their distance was not fake. So I don't want to hear, oh, he didn't throw it that far. It did. I saw the video, trust me. So I want to say congratulations to a couple people here. Grayson Ard, Kensley Ard, Lily Brown, Caden Williamson, Corbin Smith, Jacqueline Treadway, Brooklyn Ball, Rosalie Hardy, let's see, Miles Godwin, Izzy Godwin, Troy Cooper, Riley Cooper, Maddie Brown, and Judson Willis. Thank you guys for all taking the time, number one, to make your own airplanes, but put the information up here on the spreadsheet so I can see it. I'll tell you what, a lot of you beat me. My planes weren't that good, and I'll talk about that in just a second. But I want to say congratulations to Judson Willis with his own design he used, okay? 54 feet. 54 feet, and I did see it on the video, and he put all he had into it, so good job, Judson. 54 feet, wow, that's awesome. Coming in second, it looks like it was Miles Godwin with 20 feet, and third, looks like Riley Cooper with 19 feet. So good job, guys, congratulations. Remember, I told you to kind of save those designs for this week, and I'll talk about that in just a second. But before we get into today's lesson, I want to show you what my airplanes did. And to be honest with you, I was really quite surprised at the results. So you're only going to see my farthest one for each. All right, here we go. Okay guys, we're back, and as you can see from the video, the front 4, this weird boxy looking thing that really, I honestly didn't think was going to fly very well, was the one out of my trials that went the furthest. My design, I guess I'm not as good as making airplanes as I used to be, but my design actually at one point went backwards. It flew and then went behind me, so it went negative feet or negative inches. I didn't count that one because there was nothing to measure. It went behind. But I was surprised at this guy. It was kind of cool to see it do the loop, the acrobat. I know you couldn't see the top part of it because the camera cut it off. But this one right here with the length of 12.5 feet. Yep, 12.5 feet beat my design, which was only 8 feet. Okay. So last week I told you to hold on to your airplanes because we're going to do something to them this week. I want you to do 2 things, okay? And I'm going to keep that spreadsheet up, the data input, because I've added 2 new columns to it. And I want you to go back and try your airplanes again. Now, you can only pick the one that you entered here. So if you said your own design was the farthest one that flew, just use your design. If you said the Dart was the furthest one that flew, use just the Dart. If you did the Suzanne, use just the Suzanne, okay? So I'm going to just use, really, my front 4. honestly, I'm going to try this other one because I was a little disappointed in my design that it didn't go as far or farther than this boxy looking thing. Okay, so just use the one that you inputted on here that went the furthest for you. All right, so here's what you need this week. You need scissors, and if you have paper clips lying around, get some paper clips. Okay, now listen, if you don't have paper clips, ladies, what works great is those little hairpins. Okay, guys, I know you don't have hairpins laying around, but maybe your mom does, or your sister or something. Please ask nicely before you take. Okay, something that is metal but still light, but still has some weight to it. Okay, so paper clips and scissors. Now, I want you guys to experiment this week. I'm not going to tell you how necessarily to do this. I want you to kind of try it out and see what your results are, okay? Now, if you notice an actual airplane, when an actual airplane takes off, they have these little things in the back called flaps. And those flaps are usually pointed down on, I believe it's down on takeoff, if I'm not mistaken. Yes. Yeah, it's down on takeoff. And that helps to build that air pressure underneath that wing, so that air can actually help lift that heavy airplane up into the sky. All right, so those flaps, either pointed up and down, help the airplane either go up or go down. Because, you know, airplanes are heavy, guys, and it takes a lot to get that thing off the air. Think about it. With all the people on an airplane, a regular commercial airplane, plus the weight of the airplane itself, plus the weight of all the luggage, to get up in the air is pretty remarkable. And there's a lot of working parts that go into that. And the tail, not to mention the tail flaps and all that. But this week, what I want you to do is I want you to take the airplane that went the furthest, and I want you to experiment. See, I'm going to cut in each wing, I'm going to cut a flap, and I'll show you what I mean. I'm just going to take 2 cuts and then 2 cuts over here. Now, I made 2 cuts, okay, on each wing. There we go, that's better. And I've created flaps. Now I can either put these flaps up or I can bend them down, okay? You can see it pointed down now. All right, I'll do both. I would like you, if you put one side down, to put the other side down too. Keep them the same. You can try and experiment with them, one up and one down. So there's my flaps pointed down. Now, what I'm going to do is I'm going to go and test this with the flaps pointed down and observe what happens to my airplane. Okay, on your data input, the thing that you guys entered your distance and the type of plane you made from last week, I've created 2 new columns. What did adding flaps do to your plane? Okay, what did adding flaps do to your plane? And I want you just to tell me, okay, it made it go straighter, or it made it go higher, or it made it go straight down or quicker to the ground. Okay, explain to me, but tell me, with my flaps down, the plane went higher, or with my flaps up, the plane went higher. Tell me what direction your flaps were in when it had the effect, or what effect it had on your plane. Okay, I left you space there to write a sentence or 2. Don't worry if it goes outside the box, guys, and you can't see it well. I still can see it. Okay, and now, not only are you going to add flaps, there's another column on there that says, what did adding a paperclip do to your plane, or do to the flight of your plane? So I want you to take a paperclip, and I want you to, or a hairpin, like I said, and put it on the nose of the airplane, just like that. Okay, the front part, sorry. The front part of the airplane. Then I want you to throw it a couple times and see what happens. And again, on that sheet, I want you to tell me what happened to the airplane after adding the paper clip. Did it make it go longer, straighter, higher, lower? What effect did adding the paper clip have to do, or have, on your airplane? Now, we added more weight by adding the paper clip. So theoretically, you might think, oh gosh, adding more weight, it's not going to fly as far. Could be. But what about the paperclip and the flaps together? Okay. So if I were you, this is the order I would do this in. I kind of did it backwards because I was excited to tell you about the flaps. I would try it just with the paperclip first. Okay. Put the paperclip on. Give yours a couple shots. Tell me what effect it had on the airplane, adding the paperclip. Take the paperclip off. Cut the flaps. Throw the airplane. Okay? Tell me what effect the flaps had on your airplane. Remember to tell me, when the flaps were pointed down, it went whatever. Or the flaps were pointed up, it went whatever. Then, after you cut the flaps and tried it, put the paperclip back on and tell me what happened with a paperclip and your flaps. Okay? So 3 things. I want you to try it just with a paperclip. Then take the paperclip off. Cut your flaps. Try it just with the flaps. Then put the paperclip back on with the flaps and try it there. And tell me what happened with both the paperclip and the flaps. Okay? All right. I'm looking forward to seeing your results, guys. Thank you for those of you that sent pictures. I know one of you was having trouble sending them. I think Brooklyn. I still haven't gotten yours yet, but feel free, guys. My email address is up in the top, so if you're having issues with sending it through the upload section on the bottom, just email me directly and email me with any questions you have. I know I've gotten a couple from people this week, and I was more than happy to help them along. So if you have any questions, please, please, please let me know. Okay. I have a big announcement, though, before you start this week's lesson. Next week, or this coming Sunday, is Easter. Next week is spring break. Yes, we still get a spring break with all this virtual learning going on, guys. I know you've been working hard. We've been working hard, and I think everybody just needs time to, catch their breath with everything going on. So next week is Easter and spring break. The following week, April 21st, we are going to do a live STEM right here from my kitchen. Y'all are invited to do a live STEM right here in my kitchen. Wait a second. No, you're not all invited here. Even though I'd love to see you, I don't think I've had room for all of you. Plus, we can't be gathering all these people together nowadays. But we're going to do it virtual, okay? We're going to do it through Google Meets. So live Tuesday, April 21st at 1 p.m. through Google Meets. We're going to have a live STEM lesson right here in my kitchen. I'm looking forward to seeing you guys. I really, really do miss y'all. We'll talk about your results from your plane thing this week. And we will also do an experiment. Now, this is what you need for your experiment. If you just want to come hang out and watch, that's fine. If you have some of these materials and want to participate, that is awesome, okay? So let me show you the materials you're going to need. You're going to need a empty bottle, okay? An empty bottle, you're going to need to have a hole in it, just about, maybe about halfway, just a little bit shorter. You're going to need a straw, okay? And the reason being is the reason we have the hole is the straw is going to fit into the hole, all right? You're going to need some, here it is, some tape. If you don't have this kind of tape, that's fine. If you have Scotch tape, okay, masking tape. Now, what we're going to do with the tape is, if your hole is a little too big, we got to make sure we put tape around it. If you have Play-Doh or clay, you can use that too and put it around the hole here, all right? And you need one more thing. You need here we go, a balloon, okay? So you need a 2-liter bottle or water bottle. It doesn't matter, it doesn't have to be 2 liter. A straw, if you have those flexi straws like this, that'll be cool. And a balloon. But remember, before we start next week, please make sure you get the hole put into your bottle, okay? So we don't have to go over that and go through that when we see each other that time. So a whole bottle with a hole, a straw, and a balloon. And this is all for our live STEM Tuesday, April 21st at 1 p.m. through Google Meets. I will put a link up on the website for y'all. So all you have to do is click on that and we'll get everybody here. Well, I say here, but here where my computer's going to be sitting, so we can converse. Guys, it'd be great to see you, great to hear from you, and I hope you can get some of these materials together if you don't just have them lying around your house, and that you can participate in the lesson. If not, just come, hang out with us while I do the lesson, and maybe learn a little bit, okay? Listen, have a happy Easter, guys. Have a great, fun, and safe spring break. I am so excited and looking forward to seeing you guys on Tuesday, April 21st at 1 p.m. for the live STEM. That's 3rd, 4th, and 5th grade. Live STEM, April 21st, 1 p.m. Google Meets. Guys, have a great spring break. Have a great Easter again. I will see you then.